Hi guys, this is a follow-up video to the DC charging system tutorial I posted. Today we're going to be talking about your AC charging system. So as you can see, this is a rough schematic for this particular vehicle, and what we have here is your PE to your CC line. We're supposed to be producing 5 volts. Some cars produce 12 volts depending on the manufacturer. So what we're going to be doing now is to show you, or rather I'll be showing you if the car is going to accept charging or not, which means I'm going to be probing this from the back while the charger is being connected, and we're going to be calculating the voltage drop across the charging gun to your vehicle. As you can see, there are 2 resistors, 1.5 kilo ohms and 1.8 kilo ohms, and this is after the switch is being pressed. So stay with me. So we have your charging gun here. As you can see, we're probed it from the back, and we're getting exactly 4.9 volts, which is 5 volts. So we're going to be saying how the voltage drops once we plug this in. So with the charger connected and the pin pressed, we can see the voltage drop of 2.7 volts. Same thing we had on our calculations with the resistant value of 1.5 kilo ohms. So this just shows us that the vehicle recognizes the charging station. In situation whereby you don't get a voltage drop, then this the vehicle itself is not probably accepting the charger, or the charger itself is faulty. So once we release the pin, as you can see, the voltage drops further. So what we have in here is a very good result on our PP line, which we also call our proximity pilot. Okay guys, so after confirming your PA line, the next thing you want to do is to confirm your CP line, which is your control pilot. So your control pilot is basically your communication line between your vehicle and your charging power. So the first thing you need to notice is that your charging power at all time is going to be producing 12 volts from your charging power, be it your charging gun, your charging station. 12 volts constant from your charging gun. So we're going to be doing a quick test on that right now to confirm that value. So as you can see, from your PE to your CP line, we're getting 12 volts constant. I'm sorry, my hands are tweaking, so you get the point. So coming back to this, as soon as you plug the charger from the CP line to the CP line on your car, is going to detect 12 volts, and it's going to go through a diode detection point 1 and through the R3 resistor, and it automatically drops to 9 volts. I mean, there's going to be a voltage drop of 9 volts. So as soon as your control power senses the 9 volts, it goes back, the information goes back to your charging power, forming a PWM signal, pulse width modification signal. So as soon as that is completed, it goes back to your CP line, down to detection point 2, then through your R2 resistor, and it drops to 6 volts. As soon as it can drop to 6 volts, your car communication is complete, and it goes back to your charging powers and allows 220 volts from your AC charging system K1 and K2 flow into the car onboard charger before converting it into DC to go straight up to the battery. So what we're going to be doing is we're going to be plugging the charger, and we're going to be showing you how the voltage is going to drop from the initial 12 volts to 9 to 6 volts, and the charger or the car starts to charge. So for this, you can see it's dropped to about approximately 8-9 volts, and this particular charger is not well grounded, so that's why we're not getting the full communication to drop into 6 volts. But I'll work on it, try and get a good ground. And but the whole point of this video is for you to understand how your AC charging system works, how to test for it when it's faulty, and to confirm the value. So different cars have different specification, different value. So the first thing you want to do is go through the manufacturer specification and the user manual to confirm all of this before carrying out your test.